In this video, we're going to be looking at rational functions. Now, a rational function is basically, any function, p of x over q of x in this form, whenever you have a polynomial on the top and bottom. All right, so we have a quadratic on top and bottom, so this is considered a rational function. Now, the things we're going to find here just in this video are going to be the domain and the x and y intercepts. I didn't put the y there, but the x and y intercepts. So to find the domain, you just have to find the values where the denominator is equal to 0. All right. Remember, the denominator is not allowed to be 0, so we're just going to factor this, and the values where it equals 0 are the ones that are not in our domain. All right. Let's go ahead and factor the top and bottom. They usually build these so that you can factor them. All right, factors of 12 that give us -7 are going to be x minus 3 and x minus 4. Factors of -10 that give us -3 are going to be x minus 5 and x plus 2. All right. Now you always want to check and see if anything will cancel here, because that's an important thing. You'll see it in this next example. But as far as the domain goes, all right, x is not allowed to equal 5, because that would give us a 0 in the bottom, and x is not allowed to equal -2, because that would give us a 0. So the domain for this one is going to be all real numbers except, all right, so minus, except for 5 and -2. Oh, curly braces, sorry. So all real numbers except for 5 and -2. If you wanted to write that in, I think that's interval notation, it would be negative infinity up to -2, but we're not going to include -2. Union that with -2 to 5, but we're not including -2 or 5, and then join that with 5 to infinity. All right. So I know it's kind of complicated, but this is the interval notation for all numbers except for -2 and 5. All right, so we include all numbers before -2. Then we include the numbers from -2 to 5. And then we include from 5 to infinity. All right, so let's go ahead and do the y-intercept. All right, to find the y-intercept, you're just going to plug in 0 for x in the top and bottom. And I guess I can go ahead and use my factored form here. So let's plug in 0 for x. That's going to give us a -3 times a -4 over a -5 times a +2. This is going to give us +12 up top and a -10 on the bottom. So that is +12 up top and a -10 in the bottom, which simplifies to -6 over 5. All right, so the y-intercept is fairly easy. You just plug in 0 for x. You could have done it up here, and that would have been fine. Actually, that probably would have been easier, wouldn't it? Yeah, if you'd have plugged in 0 for x in the original, it would have gave you 12 over -10 immediately. So, lesson learned. All right, now to find the x-intercepts, if they exist, you just take the numerator and set it equal to 0. So you would have x minus 3 set equal to 0, which would give us x equals 3. That's going to be one of your x-intercepts. And then the other x-intercept would be +4. So you get 3 and +4. So for the x-intercepts, I just said you basically factor the numerator and then set those equal to 0 and solve. If we looked at the graph of this, I have it here in factored form already. You'll see that they often yield some wild-looking graphs here. So you can see it comes from -infinity and blows up here. That's because -2 is not in the domain. All right. And let's see, from -2 to 5 right here, you'll see it's blowing up again at 5, the x value of 5. And right here again at 5, it's blowing up. All right, let's go ahead and do one more here. On this one, the numerator is already factored for us, and the denominator, it's the difference of squares. So if we factored that, we would get, let's see here, 2x minus 3, x minus 4. And in the bottom, the difference of squares, this would be an x plus 4 and an x minus 4. All right. So you'll see here, these two will cancel with each other. If you ever have a factor that is in the numerator and the denominator, that is going to create a discontinuity. All right. It just means there's going to be a hole in the graph. So there's a discontinuity at x equal 4. All right. So this basically is going to be the graph of 2x minus 3 over x plus 4, but there's going to be a hole in the graph at x equal 4. If we wanted to know our domain, okay, we would set these factors equal to 0. So the domain is going to be, all real numbers again, except, so we'll subtract off here, be positive 4. Positive 4 is not in the domain, and negative 4 is not in the domain. Because those are the numbers that if you plug them in, you would get a 0 in the denominator, which is undefined. So, if we wanted to write that in interval notation here, I'll give you another example. It'd be all the numbers before negative 4. Okay. And then union that with all the numbers between negative 4 and 4. Okay. And then we would union that with all the numbers after 4. Okay, so these are parentheses on the 4s and negative 4s because we're not allowed to include those endpoints, right? Because if we did include them, it would give us a 0 in the bottom. Let's see, for our y-intercept, okay, we'll plug in 0 for x. So if we plug in 0 for x, we would get a negative 3 times a negative 4, which would give us a 12 in the numerator. And that would give us a negative 16 in the denominator, which will simplify down to negative 3/4. Right. For our x-intercepts, all right, this one's a kind of a special case. The x-intercepts, we would normally set this equal to 0, and we would say 4 is one of our x-intercepts. But since it canceled with one of the factors down below, it is not one of the x-intercepts. There's actually going to be a discontinuity, as we said, at x equal 4. We would set 2x minus 3 equal to 0. Add 3 to both sides, and then divide by 2. And that was going to give us x equals 3/2. Right? And that, oh, I said 3/5, my bad. 3/2. And that's going to be our only x-intercept for this graph. I'll look at that one. Okay. All right, so here's your graph. Our only x-intercept is right here at 3/2, which is 1.5. We see our y-intercept is at negative 3/4, like we said. The domain, we can see that it goes to negative infinity off to the left here, but it blows up once it tries to reach negative 4, right? Because negative 4 is not in the domain. It makes it blow up right here, so it gives you a 0 in the denominator. And if you also look at positive 4, we said there was a discontinuity there. So if you look at positive 4 here, you'll see it says undefined, and there's a little circle or a hole in the graph, right? So everything on this function is defined up to positive 4, but once it gets to positive 4, it has to skip it.